odds are that we will probably be alright. Odds are we gonna be alright. Odds are we gonna be alright tonight. The odds are that we will probably be alright. Odds are we gonna be alright. Odds are we gonna be alright for another night.
Hi, in this video we're going to talk about calculating probabilities using the normal distribution, and I'll show you how to do those same calculations in Excel. Remember, our normal distribution is a bell-shaped curve, and in this particular example I've given you a mean of 100 and standard deviation of 15. Remember, this symbol means standard deviation. Now, when we're given a value and we want to calculate a probability relative to that value, the first thing we're going to do is calculate the z-value. Okay, so for example, if I do have a distribution, mean 100, standard deviation of 15, and I want to know the probability of getting a value less than 118, then it's often easier to see this if we draw out the distribution. So the mean is 100. The mean goes directly underneath the highest point of our curve. We know 118 would be out here, okay? And if I'm calculating a value less than that, then I need to know the probability that it's in this area of the curve. Now remember, the probability of less than 118 is also the same thing as the area underneath the curve that is less than 118, okay? So we're looking for this area, and not to confuse you, it's an area, but it's also going to be the probability. Now notice that when I calculate less than, I shaded in the values less than 118. That's how I knew to go here. And in this particular case, we're looking for a left area. In other words, the area to the left of our value. And that's critical when we go to use our chart. And I'll show you that in a minute. All right, so first we're going to calculate our z-value. It's going to be equal to x. Well, we filled this number here in for x, minus our mean that's given to us as 100 divided by our standard deviation, 15. If I do this, 118 minus 100 is 18 divided by 15, and we get 1.20. Now, if we're using our table, we go to our normal distribution table, and we're going to look up 1.20. I see here that these are my negative z-values, so I'm going to look for the table that has my positive z-values. Okay. Notice here that when I look up an area in this table, it's going to give me the left area. Well, in this particular example, that's what I want, is the left area. How do we use this table? Our z-values, the whole number part and the first decimal, are located here in our first column. Our second decimal is located across the top. So I have 1.2, whole number, first decimal, so I'm going to look for 1.2, and then 0. So my second decimal is 0, so they intersect right here, so I'm going to take this value, 0.8849. And now 0.8849 is two different things, but the same number. It's the area underneath this curve, but it's also the probability that I get a value less than 118. Let's look at our next example. In this example, I don't have less than, I have greater than. So I'm going to do my picture again. 100 is right here. Now 91 would be to the left of that. Think about this as a big number line. Where would 91 go? To the left. And my values greater than 91 are going to be in this direction. And now I'm looking for this area, but it is a right area. We're going to go through the same steps as we did up here, but we have one additional step to do at the end. So what was our first step? Calculate your z-value. X, 91, minus my mean, which was given to me as 100, divided by my standard deviation, 15. Notice here, I'm going to get 91 minus 100, And if you punch that into your calculator correctly, you'll get -9/15. Keep the negative. Let me repeat that. Keep the negative. Okay, so this is -0.60. Again, I'm going to go to my chart. Now I have a negative value, so I'm not going to use the positive. I'm going to use the negative portion of the chart. All right, my whole number part is 0. My first decimal is 0.6, 0.6, and my second decimal is 0, so I'm going to go here. So I get 0.2743, 0.2743. Again, remember, this is the area on this curve, and it's a probability. But what area is this exactly? Notice that my table only gives left areas. So this is not the area that I'm looking for. This is actually the area in here. So this area in here is 0.2743. So how am I going to find the right area? Well, I know that the total area under this curve is 1, okay? If I know that this is 0.2743, then I can calculate this by subtracting this value from 1. So I'm going to take 1 minus 0.2743, and I get 0.7257. So that is going to be this right area, or my probability of getting a value greater than 91. So notice the difference here. Left area, we just take the table value. Right area, we take the table value, take 1 minus the table value. And again, this is a less than, so you can remember it that way as well. If you have a less than, you're going to take the table value. If you have a greater than, you have to take 1 minus the table value. All right, and for our last example, we have a between. Find the probability we get a value between 79 and 133. In this particular case, let's do our curve first. We are looking for an area in here. Well, that's not a right area, that's not a left area. But what we can do is we can use our table and find all of this area to the left of 133. But that's going to be too much. So then we can find the area to the left of 79 and subtract that off. Okay, so we're going to find the total area to the left of 133. Then we're going to find the area to the left of 79 and take this value minus that value to get this area in here. Okay, so what we have to do is calculate a z-value for both. Let's start with 133 minus 100 divided by 15. We get 33 over 15. And that gives me 2.20. For my next one, we're going to take 79 minus 100 divided by 15. Gives me negative 21 over 15. Negative 1.4. All right, so we calculate our two z's. Now we're going to look those up in our table. 2.20, let's do the first one first. 2.20 is 0.9861. In other words, the area from here all the way down here is 0.9861. Okay. Now we're going to look up minus 1.40. 0.0808, and now that's going to be this area in here. So to get my original orange area, I need to take this minus this. And I would get 0.9053. Now, it's just been a coincidence that all of these have ended in a 0 here. And so that is why we're always taking the first value in this first column. If I got 2.24, then I would have to go to 2.2 and come across to the 4 here. Okay, so please don't think that you always take the value in the first row. It just ended up that way because all of my values ended in 0. Let's jump over and do these same calculations in Excel. We can do them 2 different ways. The first one is using the norms dist. And if we do the norms dist, we need to know our z-values. So I'm just going to punch in our z-values. Here we got a z-value of 1.20. We'll label this column Z. Here we got a z-value of negative 0.60. And recall here we had 2 z-values, 2.20 and negative 1.40. Okay. All right, so if we use our z-value, we're just going to come over here and use the built-in function norms dist. So it's NORM for the normal distribution with an S, that means standard, and then DIST, open parentheses. And now I would just punch in my number, or in this case I can just click here and it returns my value. Notice that this was a left tail test, so I'm going to take the value. So it's left tail, in other words it's less than, so we use this value. All right, I'm going to repeat the process here. Equals norms dist of negative 0.6, okay, and it gave me the value that we got from the chart, but remember that this is a right tail, in other words it's greater than, so we take 1 minus the value. So my answer is going to be equal to 1 minus this. Okay, I'm just going to highlight our answers here so that you can see them, and that's what we got. All right, now we're going to do 2 norms dist equals norms with the S dist. Click on our value. Equals norms dist. Oops, I don't know where that parentheses came from. Norms dist. Click on our value. All right, and now this was a between. So we subtract smaller from larger. So in other words, my answer here is going to be equal to this minus this. And so this would be our answer. That's the first way of doing it, okay? We also have a distribution called norm dist. And if you use this one, then you don't calculate the z first. It's only for calculating the probability. In most of the problems you'll have on homework, they're going to want your z-values, so I strongly encourage you to calculate that. But if you just want to know the probability, you can do norm dist, and you put in your x value, so in this case it'd be 118. You put in your mean, comma, your standard deviation, and then we just type the word true. And it will just return our probability. Equals norm dist. Put in your x, your mean, your standard deviation, and the word true. Again, you have to know that this is a right tail test, so you have to subtract it from 1 to get the correct value. And then here, norm dist, we'd have to do it twice. Put in your first x, 133, 115, true. And then norm dist, put in your x, 79, 115, true, and it would calculate both. And then remember how we get a between value. Subtract the smaller from the larger. All right, so again, you'll probably use this top one more because you will be required to calculate the z. But if you just want to know the probability, you can use this one and cut out the calculation of the z. So that's how we can use Excel. And in essence, all we're doing is using Excel in place of this chart. And what it actually does is reduce our number of errors that we make, especially trying to find decimal places over.
Odds are we gonna be alright. Odds are we gonna be alright for another night.